Hello, good afternoon students. In previous class we have discussed that what are the advantages of extra high voltage and ultra high voltage AC transmission systems, both advantages and disadvantages, and brief introduction of EHV lines also. So in today's class we have to discuss what do you mean by HVDC transmission systems concept and what are its merits and demerits as compared to HVAC system. It is a well known fact by introduction of transformer the high voltage AC and transmission system becomes economical and very much popular throughout the world. There is no doubt. All over the world HVAC is popular because every system wants economical. That's why as compared to AC system or DC system, AC system becomes more popular. Therefore all over the world we depends on high voltage AC and transmission distribution systems. The diagram shows typical HVDC transmission system. It mainly consists a sending end and receiving end. Starting from the sending end, there is a generator. This is purely belongs to AC system. So number of alternators are working there. Generating station generates AC voltage. This generated AC voltage can be boosted as per your requirement of capacity or design of transmission line. This generated high voltage is given input to sending end substation. It mainly consists of rectifier units. So what is the function of rectifier unit? It converts the AC system to or AC voltage to DC voltage. Then output of rectifier up to the input of inverter circuit is known as DC transmission line. So this generated AC is converted into DC. This DC electrical power is transmitted in bulk over a long distances through overhead transmission lines. Now at the receiving end there is a inverter section which receives the DC voltage, but we can't distribute the DC voltage. It receives the DC voltage, then it converts DC voltage to AC voltage. Then again by using suitable rating of transformers, it is distributed AC to consumers. Here the generation is AC, the distribution is AC. In between there is transmission from rectifier output to input of inverter. There is a transmission line, overhead transmission lines comes. These are known as overhead HVDC transmission lines. Now you see there again same circuit, it is modified for a further explanation. So at sending end it consists AC system, then transformer, then come to the rectifier substation. There is a transmission line of the DC which consists the resistance of R. Current flowing through this one is ID. Then it goes to the inverter substation. After that again transformer, again goes to the distribution of AC system. So here Sending end substation. Sending end, it is AC voltage. Again AC voltage is boosted with the help of transformer, which is given to input of rectifier substation. The rectifier substation converts AC voltage to DC voltage. Then this converted DC voltage is transmitted up to inverter substation through the overhead DC transmission lines. The inverter substation receives the DC voltage and converts into AC. It receives the DC voltage and converts it into AC voltage. Then through the distribution of AC transformer, the AC power is distributed. Here whole the performance depends upon substations, that is rectifier, that is inverter, that is converter. Two converter stations, what is the efficiency? It depends upon performance of converter efficiency. How much you are designing efficient converters, then it is possible to achieve higher performance of DC transmission line. Then as per earlier expression, the AC voltage is generated at generating station and it is stepping up by using suitable transformer. Then it is converted into DC voltage by use of rectifier unit. This converted DC voltage is transmitted over the overhead DC transmission lines. At receiving end, there is again an inverter circuit or inverter unit which converts DC voltage to AC. This efficiency of converter, both rectifier and inverter, makes the efficiency of DC transmission lines. So that is, the advancement of semiconductor technology makes the efficient use of HVDC transmission, that is by using thyristor controlled circuits both in rectifier, both in inverter units. So thyristor is one of the semiconductor device, so its operation is controlled by the very efficient way of firing angle. So 0 to 90 degree for rectifier operation or 90 to 180 degree for inverter operation. Let VR be the DC output voltage of rectifier, VI be the DC output voltage of inverter, let ID be the current passing through the transmission line. Then this current is given by VR minus VI, voltage across rectifier minus voltage across inverter divided by resistance of the line. This is equation number 1. Then what is the power transmitted? The power transmitted in the transmission line, it is given by PD. PD equal to ID into VI. That gives equation number 2. Then we have to concentrate on some advantages of HVDC transmission line. So very first point, such transmission lines are used to transmit bulk electricity or bulk electrical power for long distances. Then it becomes economical. This point is very much useful. You remember, up to 500 kilometer. Above the 500 kilometer, transmission line becomes economical. If such lines are used less than 500 kilometer, it becomes uneconomical. It requires less number of lines as compared to three-phase AC system lines. The number of lines are required reduces, thereby cost of the conductor also reduces. Then it becomes still economical. As we are observing stability and synchronization problems in AC system, but in DC lines such problems are not available. Then skin effect is also low as compared to AC and DC system. The skin effect is more adverse in case of AC system, but skin effect is very much low as compared to AC. In DC system it is low. Very important is absence of inductance, capacitance associated with transmission line. There is absence of inductance and capacitance in DC lines, then problems associated, this inductive drop and capacitive drops are also absent. Very important is the effect of corona is more in case of AC lines, but the effect of corona is very much low in case of DC lines, and less interference with radio and TV networks. No reactive drop. Indirectly it gives better voltage regulation of transmission lines. The losses are also less, then efficiency of the transmission also goes on increases. With HVDC link there is a easy reversibility and controllability of power by using suitable control circuits in converter rotation. Convert very easily AC to DC and DC to AC, and with better controllable circuits. Very important is the fault level. The fault level is more in interconnection of AC grids with AC. It is in AC system, AC grids with AC lines. But here in case of DC lines, interconnection of AC grids through the DC links. That means in case of this DC transmission line, fault levels are less as compared to AC system. Disadvantages of DC transmission line. Already we know that if the power transmission with HVDC less than 500 km, it becomes costly. It is not economical. Once again you remember, it is becomes more economical for long distance of transmission of power. It becomes uneconomical because it requires additional converter and design of rectifier and design of inverter units. So if the lines are operated less than 500 kilometers, definitely it becomes not economical. Considerable reactive power is required at converter stations, because at the both converter stations we are converting AC to DC, and it is also known that at receiving end we are converting DC to AC. Where it AC comes, there is requirement of reactive power. So converter stations should take into consideration of reactive power while designing the stations. Considerable harmonics are developed in DC system, hence filtering circuit is necessary. Lastly, overload capacity of HVDC converter is low, hence it is one of the limitations. Then additional losses will occur in converter transformers and valves, hence it requires effective cooling system to make effective heat dissipation. And one more thing, as compared to AC system, DC system breaking, DC circuit breaking is more difficult and expensive as compared to AC system. So these are some advantages and disadvantages. Try to understand of the very first thing, the HV DC transmission concept very early. After that advantages, after that disadvantages. Separately you prepare advantage and disadvantage of DC, then try to compare with HVAC transmission system. Thank you to one and all.